All right, so welcome to today's lesson. So in this lesson, I'm going to revise sets. And then apart from sets, we'll also do a quick revision on trigonometry, and then we'll also look at quadratic functions, and then we'll conclude by looking at limits. Yeah, so this is just one application of limits. Okay, so for this question, the first one, it's asking us to say, we should find a B complement, A intersection B minus C, and A intersection B. So the most important thing that you need to do when you're dealing with sets and even just any other question in mathematics is to first understand the question. So the question here is saying, let X be equal to open brackets 1, 10, and then the universal set. So in other words, this is the universal set. And then we also have A is equal to that, and then B is equal to this, C is equal to that. And they're saying these three sets, A, B, and C, are what? A subset of X. And then X has been given to be the universal set. So meaning A, B, and C are all within X. Then the question goes on to say, find each of the following sets and display them on the real line. So this is very simple. Okay, so this is simple and straightforward. So to find B complement, okay, before I can start solving this, let me first explain what these brackets mean. So remember what I said, if we have a set, let's say for instance, you have A, comma B, then it's in these brackets. It means that we're talking about elements between A and B, and A and B are not part of the set because we're using open brackets. Then if we're using these kinds of brackets, which are called closed brackets, for this set, we're talking about elements from A up to B, meaning A and B are also part of the set. So if we have A, comma B, like this means that A is not part of this set, but B is part of the set. So it's as simple as that. Let's quickly begin to solve the questions. Okay, so now to find B complement, I know that B is equal to, B starting from 2 up to 8, but we know that 2 and 8 are not part of set B. So to find B complement, we're going to say the smallest number that is not in set B is 1, because we're trying to look at the universal set. So the smallest number that is in the universal set, but not part of set B, is 1. So I'm going to write 1 there, of course, with the bracket which is there, which is a square bracket. Then I'll say comma. Then I'll move up to 2. So I'm going to move up to 2. I'll also write my 2 there. Then I'm going to close the brackets to show that 2 is part of B complement, because this complement means numbers, or rather elements that are not in B, but they're in the universal set. So I'm adding 2 to the to B complement because 2 is not part of set B. Looking at the bracket which is there, so 2 is not part of set B. So I'm going to add it to the B complement. And then I'm going to say union because I've not dealt with 8. So I also need to deal with 8 and also 10. So to combine the two sets, I'm going to say union, and then 8 is not part of set B. So it's going to be part of set B complement. So meaning I'm going to close the bracket like that. So I'm going to say 8, and then comma, I'm going to write 10 with its bracket there, which is a square bracket. So this is exactly what you're supposed to do. So now representing this or displaying this on the real line, you simply just draw your number line. Then you have numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can put in the numbers there. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our B complement is starting from 1 up to 2, and then of course at 1 and 2 it's closed. So I'm going to draw a circle there at 1 and at 2, but since it's closed on both sides, meaning I'm going to shade. So if it was an open bracket, I would have left it empty like that without shading it. So I'm going to connect the 2. Then I'll also do the same for 8 and 10. So at 8, I'm going to draw a circle. And then even at 10, I'm going to draw a circle. Since it's closed on both ends, so I'm going to shade the circles. Okay, so this is our B complement. So the same thing is exactly what you do even on the remaining 2 questions. So let me quickly answer them. So whenever you see something like, let me give an example of A, or A minus B. So A minus B is simply just the same as A intersection B complement. If we say D minus E, this one is just the same as D intersection E complement. If I say C minus D, this is just the same as C intersection D complement. So whenever you see a minus there, it means that you have to write it in this form if you want to make your work easy. So that is known as the set difference. Okay. So meaning this expression can also be written as A intersection, open brackets, B intersection C complement. So according to BODMAS, we always have to start with what is in the brackets. So let's deal with what is in the brackets and then we'll come and intersect it with A. So let us first find B intersection C complement. So I know that my B is equal to 2,8, which is just given there. And then C complement is this one. So we have C here, then the universal set there. So the smallest number in the universal set is 1, and then it has a closed bracket. So we close at 1 and then up to 3. So I'm going to write 3. Now, since 3 is part of set C, according to the bracket which has been used there, meaning it's not going to be part of the complement, meaning I'm going to open in the complement. And then another set this side will be 6. We'll start from 6. Now, since 6 is not part of set C, means that it's going to be part of the complement. Then I'll say comma. Then I'll write my 10 there and close at 10. Of course, I'm supposed to combine the 2 sets with the union. So I have this C complement. I also have my B there. So I'm trying to find the intersection between B and C complement. So the common elements between the 2 sets is the answer that I'm looking for. So B intersection C complement will now be equal to, we look at the common elements. So I know that there is 2 in this expression, but it's not part of set B. And I also know that there is 2 in this expression. So what I can do for such a situation is I'm going to write 2 because I know there's 2 in this set. There's also 2 in this set. So I'm going to write 2. But because 2 is part of this set and it's not part of this set, I'm going to write an open bracket there to show that 2 is not part of this set, but it's present in this set and also in this set. Or if you don't want to confuse yourself, you can just draw a simple number line. I'll show you how to use a number line. And then we also have, so these 2 can, the first set here will go up to 3 because we have 3 there. So I'm going to say comma 3. but 3 is not part of this set, meaning it's also going to be open there. And then from there, I know there's 8 there. So this 8, I can say union, and then there's 8 there. So I'm going to write 8. 8 is part of this set, but it's not part of this set, meaning I'm also going to open there. Then I say comma. I'm going to have 10. Or looking at the, we're trying to look at the common elements. So we know that this, so we're trying to look at the common elements. So we know that this 2 is common, it's both in this set and in that set. And then 3 is also in between 2 and 8, so it can also be written like that. And then 8, do we have 8 in this expression? Yes, we do. So this 8 is the only common element that we have. Okay, let's start from 6 rather. We start from 6. We start from 6. So this is going to be 6 is in this set, and also 6 is also part of this set. So I'm going to write 6 there, but yeah, since it's in both sets, we know that 6 is between 2 and 8, and then 6 is also part of this set. So meaning I'm going to use a closed bracket, and then I'll say comma, I'll go up to 8. Then since 8 is not part of this set, but part of that set, I'm going to leave it open. So let us now try to use the number line so that you see how simple it is to get this same answer using a number line. So I'm going to draw a quick number line here. Then in this number line, I'm just going to put important numbers. So I'm going to put 1, I'll put 2. I'll look at the numbers which are present in these two sets, this one and this set. So I'll put 2, I'll put 3. Then there's 6, 8, and 10. There's 6, 8, and 10. So the first set, which is set B is simply just 2, 8. So it's open on both ends. So it's going to be open at 2, and at 8, it's going to be open. And then I'm going to combine the 2. So this is my B. So let me also write C on the number line. So I mean C complement on the number line. So C complement is starting from 1 up to 3. So C complement is starting from 1 up to 3, and it's closed at 1 and open at 3. Then we also have 6 and 10. So it's also starting from 6 up to 10, but it's closed at both ends. So meaning we're going to close it at both ends. So this is my C complement. This is also C complement. So to find the intersection, I'm going to shade the region where these two lines meet, the line for B and C complement. So we can say that at this region, the lines are meeting. Then we also have this region, the lines are meeting. So this is the solution, meaning my B intersection C complement is simply just going to be written as, I'll write, I'll pick the numbers below the circles. So I have the first number here will be 2, and it's open at 2, meaning I'll open at 2, and then it's ending at 3, which is also open at 3. Then I'll say union, it's closed at 6, so I'm going to close at 6, and then it's open at 8. So I'm going to open at 8. So you can see that the same answer which I got here is exactly the same answer which I've gotten using the number line. So after finding B intersection C complement, we can now intersect this same set with A. So intersecting this same set with A, I'm going to have, I think let me just add A to this same number line, or let me just draw a different one. I'll just draw a quick different number line. So I'll also just put important numbers. We have 1, we have 2, we have 3, then we have 4, which is in A. I'm trying to look at A and this set here because we're trying to compare A and B intersection C complement. So we have 3, 4, and then we have 6, we have 8. So this is the simplest way of solving sets. In short, it's by using the what is the number line. So I will first put my A. My A is from 1. My A is from 1 to 4, and it's closed at both ends. So I'm going to close at 1 and 4. Okay. So this is my A. Now let us also put B intersection C complement. So putting B intersection C complement in this expression is also straightforward. So this is my B intersection C complement. So the first part I'm going to put is 2, 3. So 2, 3 is here. I'm going to open at both ends because it's open at both ends. And then I'll also add 6, 8. 6, 8. But at 6, this will be shaded. So this is my B intersection C complement, and this is my A. So we have B intersection C complement. And then we're trying to find the intersection between these two sets, this one, which is set A, and this other set, which is this side. So to find the intersection, it means that we're going to find the common elements. So the common elements are found in the region where these two lines are meeting. So the only part which is meeting the other line is this one. So when you look at this part, this is where these two lines are meeting, the line for B intersection C complement and the line for A. So this is the only region where these two lines are meeting. So the value of A intersection B minus C is simply just equal to this same expression here. I mean, these two numbers there, and it's open at 2, and it's also open at 3. When you look at what we have inside there, so the brackets are open on both ends. So we write our 2, 3 there, then we open at both ends, since these are open on both ends. Okay. So let's also do the last part, which is this one. So we've been asked to find A intersection B. So even that one, if you want to find, the easiest way you can find that is simply just by drawing a number line. But if you don't want to draw a number line, you can just find it by observing the numbers. So when you draw the number line, I'm just going to put cardinal numbers here. So I'll put the numbers for A and B, and then I'll find the intersection. So the numbers for A, we have 1 and 4. Then in B, we have 2 and 8. So I'm going to put 1, 2, 4, 8. So A is ranging from 1, and it's closed at 1. So if you don't want to be shading the brackets, you can be using the same brackets. So you put a square bracket at 1, and then also a square bracket at 4. Then for B, it's open on both ends. So B is starting from 2. So at 2, it's open. So you put an open bracket at 2. And then you also put another open bracket at 8. So this is the other way you can represent this on a number line, if you don't want to be drawing circles. And then we're trying to look for the intersection, say, between A and B. So this part is the intersection where the two lines are meeting. So in writing the answer, you can say A intersection B is equal to, so it's open at 2 and then closed at 4. So you can even draw another number line to represent your answer there, which is just 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you can put your numbers. You put your numbers there, Then you write your set, which is 2, 4. So it's open at 2 and closed at 4. But if you want to use circles, you leave the circle open at 2, then you shade the circle at 4. Still the same. So this is how you deal with sets. Do we have any questions before we proceed to the next question? Okay, so let's quickly move to the next question.